All right, you guys, welcome to Homework Help for Chapter 2, number 3. Okay, I'm going to try to move this around so I can see it a little bit better. There we go. Hopefully the lighting's not too bad, but we'll manage, won't we? All right, so we're going to start with this question, the Super Ball question. This one's actually not that tricky, with the exception of direction. That's what usually throws folks for part of the time. So if you are struggling with this question, what I'd like you to consider when you're finding acceleration is that if you are rebounding, you are changing direction on your velocity, right? So let's say that you're making this the positive way for your initial velocity. Your final velocity going the other way is going to be negative. Now remember, when you do a change in velocity, which is really, let's face it, that's the definition of acceleration, isn't it? That's the change in velocity. And you have final minus initial, well, you've got to be careful with your negative signs, is what I'm saying. Okay, because it's changing because of the direction change, and you have to carry it into the formula. Whenever you rebound something, it actually has a far greater acceleration than if something just, say, hits a wall and comes to rest. So do keep that in mind as you're working here, and don't be surprised when your answer is a giant answer. Okay, that's correct. That's normal. Okay, so there's number one. Let's move on to number two. Number two looks tricky at first because it's a graph and it's an acceleration graph. But if you'll notice, we have constant acceleration here. We've got constant acceleration here. It's of 0. And you've got a constant acceleration down here. In my case, I don't know if all the graphs are the same or not, but mine's -3 meters per second squared. This one's 2 meters per second squared. Okay, so determine the particle's speed at 10 seconds. Well, at 10 seconds, it's been accelerating the entire time at this constant positive velocity. So let's face it, what are we trying to find? We're trying to find VF. And it tells you in the beginning of the problem that you start from 0. And you know the time, and you know the acceleration from the graph, and you're solving for VF. That's a pretty straightforward kinematic relationship. You know, just find the formula that works for you and plug and chug. What's the speed at 20 seconds? All right, keep in mind that you are changing velocities for a while. All right, so here, up to the 10-second point, we are accelerating. We have an acceleration. Then it travels for 5 seconds with no acceleration. If you have no acceleration, remember, this is the relationship that applies to a non-accelerating particle. Okay, that's our constant velocity relationship. It doesn't happen very often. But if you are traveling with constant velocity, you have to consider that it's not going to stop moving. It's going to move. It's just not going to get faster and faster as it goes. So you're going to have a velocity at the end of this motion. That velocity is going to continue through the end of this motion. And then you're trying to find a final, this then becomes your new initial velocity here at the beginning. And then, of course, you want to find your final velocity here when you have a new acceleration in the negative direction. So you have all the pieces that you need, but just realize that your final velocity from this point is going to become your initial velocity at this point, and then resolve for your final velocity over here using the same kinematic relationships that you had. All right, you have a new time interval, you have a new acceleration. Shouldn't be too bad. And then your last question here, find the distance traveled in the first 20 seconds. Okay, well, you're going to want to find delta x for the accelerated part of the motion. You're going to want to find delta x for this part of the motion where it's not getting any faster, but it's still moving. And here you're going to want to find delta x for this accelerated motion. Don't be fooled in thinking that it suddenly leaped backwards just because you have a negative acceleration. When you put the brakes on your car doesn't leap backwards, thank goodness, right? We'd all be in trouble. But you will obviously be moving forward, not quite as rapidly, so you should, your value will be decreased somewhat because you're not accelerating in the same direction as your velocity. You're slowing down. Adding the 3 together will get you to your distance traveled in the first 20 seconds. Just treat it as 3 separate parts: accelerated motion, non-accelerated motion, accelerated motion. Be careful with your signs for negative acceleration, and then add them up. Okay, let's move on to number 3 and 4. Now I'm going to apologize. Every year I try to use my same assignments, and I'll get this message that WebAssign has updated the question, and most of the time I just say, oh, that's great. Go ahead, update it. Be my guest. But then every once in a while, they update it in a way I don't expect. So when I printed this out and I started to look, you notice I wrote remove. The reason for that is because of Part B. Now, I know a couple of you worked ahead and you probably, you know, went on Yahoo Answers or asked somebody else how to do it. But quite honestly, it's not that you can't do A, it's just that we haven't done B yet. B involves calculus. So I took the question off the assignment. It doesn't mean you're going to lose anything. In fact, I think I want to say that Jerry, you did all 22, and yeah, right now you have a 244% on this assignment because, yeah, the points stay there. But I did take this entire question off. You will see it again a little bit later, but I'm not going to waste time with it. The same thing, unfortunately, did happen with number 4. This question had a different focus the last time I had it assigned, and quite frankly, I don't think it's the most useful question for you right now. Not that it's impossible to do, but it's kind of a piddly little thing. Do keep in mind, you know, your average acceleration, you're looking at the slope of the line. You've got curves in here. We're not at the point of using calculus yet because they put in just barely enough flat, constant slope. I shouldn't say flat, I should say constant slope. There's enough constant slope here that you can actually take some averages. But you know what? That's really not the most useful skill for you. What I do want you to understand is that the acceleration is, of course, the slope of the line here. It's the change in velocity over time, and find it there. Where's the acceleration? 0, where you have no slope here at the top. Where do you have the most positive acceleration? Well, it's going to be up here. Where do you have the greatest negative acceleration? It's going to be over in here. Oh, and there's 0 acceleration as well at that point. But otherwise, I don't think the focus of the question is really that helpful, so I took it off as well. So, lucky day, right? Okay. I guess if you didn't start your assignment yet, it pays to procrastinate a little until Mrs. Grady gets the video up. Yay. All right, so number 5, which is now, I think, number 3. Whatever. It's newly numbered, but you'll recognize it, the truck. This one is a very straightforward question. So you are given displacement, you're given time, you're given final velocity because you're slowing down to a final speed that they give you, and you're being asked to first find your original speed and then find your acceleration. An accelerating object, you are not going to use your constant velocity relationship. Just remember that. All right, this relationship, no, because it's an accelerating object. You need to work with one of your 3 kinematic formulas that have acceleration, and whichever one you have the most information on, I would use that. And that's all I'm going to say about those. That is a very, very straightforward one. Okay, your acceleration should turn out to be a negative number. And notice here in my answer, although yours will be different, it's a negative value. So make sure it's a negative value. Okay, and not just because you made it negative, but because it is negative. It should show up naturally in the math. Okay, our last question. Let me fold this here. This one also is another very straightforward kinematics equation, or I should say application of the kinematic equations. What you're going to want to do here is you're going to want to pull your variables out, identify them, and then solve for the missing pieces. So you're given an initial velocity of the plane. You're told the acceleration. They don't tell you directly, but let's face it, we're slowing down. So make sure you realize that your acceleration is negative. And the final velocity is 0 because it's coming to rest. The first thing you're asked for is the time. Again, pick a kinematic relationship where you have everything there except for the time and solve. And then can the plane land if the runway is X amount long? Well, that's easy enough. It's a yes or no question. You know, you can tap away until you find it. And then what is the minimum distance? So now you're going to solve for it, but do recognize it's in kilometers. So make sure that you change it appropriately. All right, so there's your first one. Hopefully not too difficult, especially after I take those questions out. And if you were working ahead, good for you. Sorry about that. Talk to you in the next one.